So we are doing a challenging questions. So today is day one and we are starting with the difficulty of easy, and question is finding the second largest number from an array. So here given a question like we have an array of positive number and we have to return the second largest element from the array. And here is the condition is given like second largest element does not exist, then we have to return -1. And here is a note like second largest element should not be equal to the first largest element. That is the largest element. So here is an example like this is our array. So in this array we can see that our first largest element is 35 and second is 34. So we will get output as 34. So let's do coding. So this is the function of second largest. Here I will remove this and let's start with like first we have to check the conditions, test cases we need to follow. So first one we need to check whether it is means whether it is having the second element, that is array should be at least less than, means it is less than, or so it should be greater than 2. So here we like if length of an array if is less than 2 means like we have an array like just one element in an array, then we cannot find the second largest element. So we have to check here. So if it is less than 2, then we will just return the -1, means we don't have second largest element. Now we will write a condition. So we will write two variables. First one is like first largest is equal to -1 and second largest is equal to -1. So actually we don't know anything. So we are assuming we are assuming -1 for both. Now here as this is an array, we have to go with the for loop because we have to iterate over each other. So here we will take for x in array, and in this array we will check condition like if x value is greater than the first largest element, then what we will do is, so x value means the here you can see 12, so x is a 12, so 12 is greater than first largest element. Currently it is -1, so it will be automatically this is true that x is greater than first element. So we need to, then our second largest will be our first largest, because here we are changing because first x is greater than the first largest, so we will make here first largest is equal to x. Then if the condition fails, like here you can see x, if x is less than the, if we first largest, then we have other condition like else if x value, then we will check x value greater than the second largest, and also we will make sure here they have given that the second largest element should not be equal to the first largest element. So here we will make sure that it is not true, so we will make x is not equal to first largest element, and if this condition is true, then we will make the second largest element is equal to x. So this is the condition. Now one more we have to check that here array length is more than 2, but we didn't find any largest element. Like here we have an array like 10, 20, sorry, so we have like 1, 1, 1 and 1. So this is an array which is greater than 2, so it will bypass this condition and go for it. But here we can see that here x value is greater than second largest, but also it is equal to the first. So here condition fails, so we have to check another condition like if second largest element is equal to, still it is -1 because it doesn't go inside this, then we will return that -1. So it means we don't have um, second largest element, and finally we will return our array. Sorry. Finally, we will return second largest element. So that's it. So this is our logic for finding the second largest element, and it will pass all the test cases because we have already handled all the test cases. So you can see here I have two function call. So let's call first. Here I am thinking so here one bracket is missing. So let's call this one and again this one. So run this code. Okay, so here is spelling second largest element, and here one bracket, and here. Okay, now again we will run this. So you can see we got 34 and 20. Now let's write another condition. So just now we have seen this array, so here is showing. So I will, when I call this again, then we can see that I got -1. It means we don't have second largest element. So this is our day one first question. Similarly, we will do more two questions. So let's go with our second question. So here is our problem 2, where here you can see we have to move all zeros to n from an array. This is also easy level, and you can here question is given like we have an array of non-negative integers, and here the task is to move all the zeros of an array to right end while maintaining the relative orders of non-zero elements. Okay, and here you can see that the operation is performed in place, and whereas we should not use any another extra array for extra array. So here is an example, like we have an array, and from this array you can see we have pushed all the zeros to the end. So in this output you can see, so we have to do that. So let's start coding. So first what we have to do is we need to check whether we have, like, we should not be like array is less than 1. At least there should be an array. So we will make sure it is not empty. So if length of an array is less than or equal to 1, in this case what we will do is we will just simply return our error. Now what we will do is, here we will use a pointer to track the element. So first we will create pointer is equal to, and we will initialize this 0, and now we will loop through the array. So for I in range of an length of an array, which will be here we will check whether um, we will go in reverse way. So first we will set the positions here, all the positions of an element which is non-zero, and then we will set zeros to the end. So further we will check if I if array of I value is not equal to 0, then we will make like array with pointer, means at 0 position we will make it like array of I. So here you can see we have 1 and I pointer is 0. So at 0 position, if it is not equal to 0, then we will set same number. So that is what it is here doing. And after this, if it is not 0, then we will update our pointer by 1. So here it is updated. So it will next, it will look for the other element. So here you can see is 2. So 2 is non-zero, not equal to 0. So it will go here, and at pointer becomes 1, so 1 position it will be 2 only. and here you can see it is equal to 0. So when it is equal to 0, then we will set it to the end of the array. So here we will create while our pointer is less than the length of an array. If it is less than length of an array, so here you can see in this case our pointer is here 0 and here is 1, and after this a pointer becomes 3. So here you can see still pointer is 2 and length of an array is like 1 2 3 4 5 6 7 8. So still it is here, it is, this condition is true, like pointer is less than an array. So what we will do is like we will make like at this pointer means we will take this element and we will make it 0, and then we will update our pointer again. So pointer plus equal to 1. So here what we are doing, like, so the here you can see we have a 0. First we have pointer is 0, then we updated to 1, and then at the third condition is failing, so it went here. So 2 is less than the 8, which is true. So here we are making like array of 2 means, sorry, array of 1. So array of 1 is equal to 0. So it will become like, here it is happening like 1 0 and 0 3 some like this, and we are updating the pointer. So again it will go here, again it will go for go in this. So in this way it will make sure that the all here it will make sure the numbers which are already there, they will be fixed in their position, and the numbers which are zeros, we are storing another position and updating the pointer. So here, okay, and finally we will do, what we will do is return our array. Now that this is our logic, let's run this code and see whether it is working or not. So you can see here all the elements of zeros are pushed to the end. So this is how it works. So let me show how this function works. So if you come here, we will take small array like 1 2, like 1 0 3 0 4, and here when pointer is 0, pointer equal to 0. So in this condition, so here when pointer is equal to 0, so at that point it will go in this loop and checks first element is 0 or not. So it is 0, you can see it is not 0, 1 is not 0. So what it will do is like array of 1 means, sorry, array of 0, which is our pointer, will be is equal to 1 only, that is array of 0 which is equal to 1. So it will be fixed at 0 position, it will be 120. Next, and here we will update our pointer equal to 1. Pointer will update to 1. So now pointer is equal to 1. Then it will go again, and in this side it will check. This is our pointer what position. So here we'll check like array of 1 will be is equal. It will check whether it is 0 or not. So you can see here array of 1 is 0. So it will not go inside this method. Instead it will um, instead it will skip this 0 and 0th one and go for this. So now it pointer 1 only, it will go here and check whether it is 0 or not. It is not 0, then it will set like at pointer 1 will be is equal to array of this I means which will be 0 1 2, which is equal to 3. So till here what happened is we have fixed like 1 2 in the same array only. We are not doing any creating any other array. In the same array only we are making like this. And after this again we are updating here the pointer to pointer equal to 2. Now again it will go and check. So when pointer is 2, it will go again into this if condition and checks whether it is 0 or not. So here you can see it is 0. So it will skip this and next it will go to this and check whether it is 0. So it is not 0. So here it will make like array of 3. Sorry, array of 2 will be is equal to, as pointer is 2, is equal to array of um, it is like 0 1 2 3 4. So it is 4. So we till here we fixed like 1 2 3. Sorry, it is 1 1 3 4. So till here we have fixed this one. Now in the same array what we will do is, now all the non-zero elements are aligned in order. Now what we need to add zeros at the end. So here this function do like, you can see here the array length is here is 3 and our original is something like 8. Oh sorry, here you can see it is like 4. No, length of an array here is 5 and it is 3. So here pointer is 3 less than 5 is true. So for the remaining length which is like 5 minus 3 is true. So 2 zeros we will generate from here. So by this it will add in the same array, it will add like so till here we have this thing, right? Now here it will go and for pointer 3, because here it is we have updated it. Here we have updated our pointer to 3. So now for at pointer 3 we will add zeros. So like it will add like 1 3 4 0, and again we will update our pointer to 4 and we will again add 1 1 3 4 0 and 0. So in this way it works. So let's go with the other question. So now let's go with the day one last question, which is reversing an array. It is also easy question, and here question is given like we have an integer array and our task is to reverse the array. And here is note that we modify the array in place, not we will not create another array. So here is an example. This is our array and output is like it is reversed, like here is 1 4 3 2 6 5, and after this function we will get output like 5 6 2 3 4 1. So let's start writing our logic. So first, before anything we will check condition, like whether the array is empty or just only have one element. If it is one element we cannot reverse it, so that is only our result. So what we will do is like here we will write if length of an array is less than or equal to 1, then we will return just array. So till here we have checked for the test like whether it is empty or one element, we have to return that array. Now here for reversing we will use two pointers. So what is two pointer means, we will use two variables and we will place like at start of an array and end of an array, and then we will slowly come near to each other. So that is a two pointer. So here if we can see, we will make pointer 1 is equal to 0 and pointer 2 which will be equal to our last length of an array. So length of an array minus 1. So this is pointer 1 is at beginning and pointer 2 is at last of an array. So now we will make, here we will write a while condition, like while pointer 1 is less than the pointer 2, pointer 2, pointer 1 is less than pointer 2, then we will swap it. Swap the elements which are at those pointers. So what we will do is array of pointer 1, array of pointer 1 and array of pointer 2. We will just like, we will write swapping means we will just for pointer 1 we will write the pointer 2, array of pointer 2, and for pointer 2 we will write array of pointer 1. So that's it. Now our array elements are swapped, the beginning element and the last element got swapped. Now after swapping we need to move the pointer toward each other. For that we will, what we will do is we will make pointer 1 plus 1 plus increase by 1, and we will pointer, but pointer 2 we will decrease by 1. So they will come together. So this make our array reverse. Now just we will return our array. So I think you have got the logic. It is simple. Two pointer is nothing but we will create two pointers begin at the start and for the end, and based on when the pointer 1 is less than the pointer 2, then what we will do it, just we will swap those elements at that pointer, and after swapping just we will increment the pointer 1 and decrement the pointer 2. So by this they will come together in by step of 1, and finally we return our array. So this is an print statement where I am calling this function with an array. So let's run this. So you can see here we got like, here our array elements are 1 4 3 2 6 5, and we got reverse of that 5 6 2 3 4 1. And also we can test these conditions. So if I, here if I print like print array reverse array, and here I will pass like elements like 1, just one element, and if I run this, and you can see we got 1, and if I pass here 2, then obviously it will reverse to 1 2 will become 2 1. So this is a logic. So thank you for watching. um, on day 2 we will continue this challenge. So thank you for watching, and do subscribe and like and do comments. Thank you.